Hi, and welcome to Math 243 Introductory Statistics. Here's your first video lecture. And in this video lecture, we're going to be talking about, 1.1, definition of statistics, probability, and some other key terms. So, what is statistics? Well, statistics is simply the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. In this course, we're going to learn how to organize and summarize data, and that's called descriptive statistics. We're also going to learn about probability and probability distributions and how to draw conclusions from good data. This is referred to as inferential statistics. And if this seems fast, this is an overview. We're going to go well into these topics. And the goal of our statistics is not to perform a ton of calculations, but really to be able to understand what's going on with the data. And we can be more confident in the decisions we make based on the data. One of the other things we're going to study, and the basis for this is called probability. Probability is what the mathematical tool we use to study randomness. For example, if we tossed a coin 4 times, we could possibly get 2 heads and 2 tails, but we could also get 4 heads, or we could get 4 tails, or any combination of those. However, if we tossed a coin 4,000 times, we're going to get pretty close to 2,000 heads and 2,000 tails. And that's what we're going to use to help make our predictions, probability. The basis of statistics is on the theory of probability. Using probability to predict likelihood of an earthquake or of rain or getting an A or any of those things. All right, so let's jump right into some key terms that we need to learn for this class. The first term we're talking about is the population. In statistics, this is the group we are studying. They could be a collection of people, things, or objects. Here's an example. Determine the population in this example. We want to know the average or mean amount of money first-year college students spend at Evelyn Benton Community College on school supplies that do not include books. So we randomly surveyed 100 first-year students at the college. 3 of those students told us that they spent $150, $200, and $225 respectively. So what is the population that we are trying to study here? Well, there's a couple of different groups in this. There's the people that told us the dollar amounts, the 3 students. There's the 100 students that filled out the survey. But the group we're actually interested in is all the first-year college students at Lynn Benton Community College. So the population we want to know about is first-year students attending LBCC this term. A sample is a way we study a population. The idea is you pick a smaller portion of the population and study from them to gain information about the whole population. Let's think about the sample in our example. This is the same example. What is the sample that we chose? Well, we randomly selected 100 first-year students. Those 100 first-year students could be our sample. We could have enrolled them. They could all be in one class if we wanted them to. It just depends on how we did the sample. So the 100 students that we asked to fill out the survey is our sample in this example. Next term is experimental unit. An experimental unit in statistics is one member of the set of entities that is being studied. So what is our experimental unit in this example? Well, we're going to use the experimental units to tell us about the whole population. In this example, we have 3 bits of data, $150, $200, and $225. So one of those guys is going to be one of our experimental units because those are one we have information about that could tell us about the general population. Parameter. A parameter is a number that is a property of the population. Okay, remember, parameter is a property of the population, though PPP. It takes a lot of time and money to examine an entire population, and that's why we use sampling. So what is our parameter in this example? Remember, it's going to be a quality of the population. Well, the parameter we want to know about is how much first-year college students at LBCC spend on school supplies that do not include books. All right, so the average amount of money spent excluding books by all first-year college students at LBCC this term is what our parameter is for this study. And a statistic is about the sample. Statistic and sample start with the same letter, so that's easier to remember. And for example, if we considered one math class to be the sample of the population of all of our math classes, then the average number of points earned by students in that math class at the end is an example of a statistic. So a statistic is something you calculate on a sample, okay? So what is our statistic here? If we want to know the average amount of money spent by first-year college students, we have to look at our sample, right? We randomly surveyed 100 first-year students at the college. We need to find the average that those 100 students spent to find the statistic. What is a variable? A variable is something you've probably heard of in math a lot of times before. It's used similarly, but maybe a little differently in statistics. For one thing, we're always going to use capital letters, usually X or Y or Z. And it's going to be a characteristic of interest for each person or thing in the population is going to be represented by a variable. So let's figure out what our variable is in our example. What do you think is going to be a characteristic of the population? The variable could be the net X equals the amount of money they spent, excluding books, by one single first year student attending LBCC. So that's our variable. A little more about variables. They can be numerical, like they were in this one. The money you spend is a number, or they could be categorical. So numerical values literally take on values, numbers, hours, weight in pounds. It's numbers. Categorical variables place a person or thing into a category. So X is the number of points earned by one math student at the end of the term. X would be a numerical value. If Y was a person's political party affiliation, then maybe Y would be Republican, Democrat, or Independent. That puts people into a category. My dog is barking a little in the background, so please ignore that. He's having a bad dream, I guess. Data. Data are the actual values of the variable. They may be a number or they may be words. It could be I earned 90 points in math or I am independent. Datum is a singular value of data. So let's determine our data. What was our data from the same example about the LBCC school supplies? We have 3 data points, 150, 200, and 225. And those are all numerical data values. All right. Now we're going to give you a chance to try your hand at this. I would like you to identify the following in this study. And there's a link, but I'm going to post it in the next slide as well. I would like you to find the population, the sample, the variable, and the data for this example. And let's read it together. Flacco, enough. Study links college students' grades to sleep schedules by Victoria Knight, CNN. Staying up late to cram for an early exam may not be doing college students any good, according to a new study focused on college students and their sleep patterns. The study, published Monday in the journal Scientific Reports, says college students who did not go to bed or wake up at consistent times every day were more likely to have lower grades. For the study, 61 students from Harvard College kept online diaries of their sleep schedules for 30 days. Researchers identified 2 groups: regular sleepers, or those who went to bed and woke up at about the same time every day, and irregular sleepers, who had different sleep patterns every day. There were several differences between regular and irregular sleepers, including significant differences in grade point averages. Using a unique scoring index from 0 to 100 to calculate a student's sleep regularity, students with very irregular sleep patterns were given lower scores close to 0, while more regular sleepers were given higher scores close to 100. The researchers found that for every score increase of 10 on the regularity index, the student had an average increase of 0.1 in their GPA. So what I would like you to do is pause the video right now and go back and figure out what is the population, what is the sample, what is the variable, and what is the data. Pause the video right now and figure that out. All right, were you able to figure it out? Well, what is the population we're interested in studying here? Well, the population is college students. College students, that's who we want to know, right? And of that population, they did a sample of 61 students from Harvard College. So that is your sample, 61 students from Harvard College. I forgot my third question. Oh, yeah. What is the variable? What is the variable that we're assigning a number? Well, they said they used a unique scoring index from 0 to 100. So that to calculate the student's sleep regularity. So that unique scoring index about sleep regularity, that is our variable. And remember, it could go anywhere from 0 to 100. So it's a numerical variable. And what is our data that we have here? Well, they said that they gave each student a score from 0 to 100. So those scores would be our data. We don't have access to them right now, but those scores would be the data that we used. So to summarize, the population was college students. The sample was the 61 students from Harvard College. The variable was their numerical sleep regularity number. And the data would be all those 61 students' values based on their sleep journals. Now let's talk about one more topic. Let's see about if a parameter or a statistic. It says, Consider the results of this study. Every 10-point increase in sleep regularity increased zero point 0.1 in GPA. Is this a parameter or is this a statistic? Remember, parameters tell you something about the entire population, and statistics tell you something about the sample. So, is this result that they got, is that about their entire population or is it about the sample? It's about the sample. So, this is definitely going to be a statistic they computed on the sample. All right, now you're ready to go try the homework 1.1 in My Open Math.